Out there, ice is rock. The first thing to change is the word. Ice on Earth is a soft, temporary material. It sits a few degrees below freezing, it creeps, it melts in your hand, and it never lasts long. That is not because of what ice is. It is because of where we keep it. Our ice is always close to its melting point. Move it out to Jupiter. There, the surface of a moon sits at about 110 Kelvin, which is around 160 degrees Celsius below zero. Water ice at that temperature is not slushy or soft. It is a rigid solid with the strength of rock. You could quarry it, you could build with it. Meteors strike it and leave craters with sharp rims that stay sharp, the way they would in stone. This single fact rearranges the outer solar system in your head. Those moons are not snowballs. They are worlds with crusts, and the crust happens to be made of frozen water rather than silicate rock. Mountains stand on them. Cliffs hold. Faults open and stay open, and underneath, where pressure and heat rise with depth, the same material behaves the way rock does deep inside the earth. It flows, slowly, over thousands of years, without melting. Glacier physics and mantle physics are the same physics with different numbers. So when we say a moon is made of ice, we are not describing something fragile, we are describing bedrock that happens to be water. The giants are big because ice was lying around. In the young solar system, there was a line, and everything about the planets follows from which side of it they formed on. Close to the sun, it was warm enough that water existed only as vapor. Solid material there was metal and rock, and there was not very much of it. That is the inner solar system, and everything in it is small. 4 rocky planets, and if you added all 4 together, they would still be a rounding error next to Jupiter. Past a certain distance, water froze. Astronomers call that boundary the frost line or the snow line, and its position in the early solar system is usually placed somewhere near the outer asteroid belt, though the number moved as the young sun changed. Beyond it, ice was suddenly available as a solid, and there is far more water in the universe than there is rock. Bodies growing out there had several times more material to sweep up. They grew fast, and once a growing body got large enough, it could hold on to hydrogen and helium gas as well, and then it grew enormously. That is the standard account of why the outer planets are giants and the inner ones are not. It also explains the moons. A giant planet forming out there was surrounded by its own small disk of leftovers, and those leftovers were mostly ice. Jupiter and Saturn each ended up with a system of icy moons that looks like a solar system in miniature. So the ice is not an accident of the cold. It is the reason the big planets are big. A comet does not melt. A comet spends almost all of its life far from the sun as a lump of ice and dust, a few kilometers across, dark and inert. When it comes close enough, the ice does not turn to water. The pressure around it is zero, and at zero pressure, water ice does not have a liquid stage at all. It goes directly from solid to vapor. The word for that is sublimation, and it is what dry ice does on a table. The gas leaving the surface drags dust with it, and the comet grows a fuzzy head that can be larger than a planet, produced by a nucleus the size of a small city. Then there is the tail, and it points the wrong way for most people's expectations. A comet's tail does not trail behind it like smoke. It points away from the sun, always, because it is being pushed outward by sunlight and by the stream of particles coming off the sun. On the way in, the tail follows. On the way out, the comet chases its own tail, which runs ahead of it. We know the nucleus well now, because a spacecraft went and lived beside one. Rosetta escorted Comet 67P for 2 years. What it found was a body darker than coal, reflecting about 6% of the light that hits it, in 2 lobes joined at a neck, with cliffs and boulders and pits, and its density is about half that of water. If you had an ocean large enough, a comet would float in it, because most of the inside is empty space between loosely stacked grains. The thing that looks brightest in our sky is one of the darkest, emptiest objects we have ever visited.